Question 1. A particle of mass 1 kilogram rests on a smooth horizontal table between two vertical walls which are 6 meters apart. The particle is joined to each wall by means of two horizontal elastic strings. Both strings have natural length 1 and elastic constant 2 newtons per meter. The particle is released from rest from a point 2 meters from one wall. We want to show that it will perform simple harmonic motion. So here the equilibrium position would be at the midpoint between the two walls. So that means it would be 3 meters from either wall. Now if we displace this particle some distance s to the right of O, the particle is now at the point P. This means that the distance from P to B would be 3 minus s. Now if we examine the forces acting on the particle, we've got a force to the left, that's the tension of the elastic to the left, and we've got a force to the right. Now here the particle was in an equilibrium position at the point O. A force was applied to the right to move it to the point P. And that force is the force to the right minus the force to the left. The force to the right and to the left are both given by Hooke's law, which is K on L minus L0. Now here the mass was 1, the acceleration is A, the elastic constant for the elastic on the right was 2, the length of the elastic on the right is 3 minus s, and minus its natural length is 1. Minus the elastic constant for elastic on the left was 2, the length of the elastic on the left is 3 plus s, that's the distance from A to P, minus its natural length, which is 1. And if we multiply out on the right hand side, A then equals 6 minus 2s minus 6 minus 2s. And the 6's cancel, and this means A equals minus 4s. And since the acceleration does equal minus a constant times the displacement, this means this particle does execute simple harmonic motion with omega equals 2. Omega squared is 4, so omega is 2. Next of all, if we want to calculate the periodic time, t is 2 pi over omega, so this means t is going to be 2 pi over 2, which is just pi seconds. And then we want to find its speed when it's midway between the walls. So when it's midway between the walls, that means it's at the equilibrium position O. That means its displacement s is 0. Now we were told that the particle was released 2 meters from the right hand wall. That means that it's 1 meter away from O, so the amplitude is 1. When it's at O, s is 0, and we had the angular velocity omega is 2, and we have to calculate v. So if we use the v-was equation, v squared is omega squared on a squared minus s squared. This means v squared is going to be 2 squared on 1 squared minus 0 squared. This means v squared is 4, and then v equals 2 meters per second.